Context rot in AI models. Executive summary. Context rot describes performance degradation in AI models as context windows fill up. Attention mechanisms dilute numerical focus across massive token inputs. This dilution causes models to ignore vital instructions in the middle of long prompts. Vibe coding accelerates this decay through rapid pasting of raw logs and redundant code blocks. Consequently, models introduce silent bugs, instruction drift, and security flaws. Developers can mitigate context rot by clearing chat histories, summarizing states, using retrieval systems, and modularizing code tasks. What is context rot? Large language models process input text through a defined memory space called a context window. Artificial intelligence developers constantly expand these context windows to accept larger documents, code repositories, and chat histories. However, output quality drops as the context window fills with text. Computer scientists call this specific degradation pattern context rot. Context rot occurs when an AI model forgets, misinterprets, or ignores specific instructions within a long prompt. The model does not crash or generate blatant error messages. Instead, the system produces responses of progressively lower quality. A model can follow every instruction in a concise prompt with high accuracy. That same model fails when you surround those instructions with thousands of extra words. Context rot differs from complete system failure. The AI continues to generate fluent sentences and plausible computer code, yet the output strays from your explicit constraints. The model loses track of subtle details in the middle sections of long text blocks. Researchers call this pattern the lost in the middle phenomenon. AI models prioritize data at the very beginning of a prompt. They also pay close attention to recent text at the end of a prompt. The model neglects data located between these two boundaries. As context accumulates, irrelevant information floods the active memory space. This extraneous text introduces mathematical noise into the processing pipeline. The AI struggles to extract critical facts from this surrounding noise. Consequently, output accuracy degrades as conversation length increases. Why does context rot happen? Transformer architectures power modern large language models. These architectures calculate mathematical relationships between tokens using a mechanism called self-attention. The computational cost of self-attention scales quadratically with input length. When a prompt expands, the model must divide its fixed attention budget across millions of potential connections. This distribution dilutes the focus of the neural network. The model spreads its attention weights across too many competing tokens. Important instructions lose their mathematical priority. Noise overshadows primary constraints. Key-value caches also contribute to context rot. Systems use key-value caches to store attention calculations in hardware memory. This storage speeds up response generation for long conversations. However, old calculations preserve early context states and stale references. As conversation length grows, errors accumulate inside the cache. The model reads its own previous outputs as authoritative source truth. Flawed outputs cycle back into future generation steps. Position encodings create another hardware constraint. Models assign numerical positional values to track word order in a sequence. Long context windows push positional numbers beyond optimal ranges. The AI loses spatial precision across long documents. It misattributes distant constraints to immediate code blocks. These algorithmic limitations guarantee quality degradation in massive prompts. Does vibe coding make it worse? Vibe coding significantly accelerates context rot. In vibe coding workflows, developers write software using iterative natural language instructions. They rely on AI models to write, test, and refactor raw code blocks without manual editing. Developers paste full terminal outputs into the chat window to debug errors. They paste entire source files repeatedly to request small feature additions. This workflow rapidly bloats the active context window. A single coding session can accumulate tens of thousands of tokens in minutes. Much of this accumulated context consists of obsolete code and failed logic attempts. The AI model processes this entire history during every new turn. It treats discarded debugging strategies as active structural constraints. The session loses a clear single source of truth. The AI confuses past broken code with current architecture targets. Vibe coding creates a rapid feedback loop of low-quality context expansion. Developers prioritize rapid iteration over strict context hygiene. They dump raw stack traces into the prompt window. Stack traces contain hundreds of lines of irrelevant framework warnings. The attention mechanism wastes computational budget on these useless lines. Thus, vibe coding creates ideal conditions for context rot to ruin software projects. What kind of problems does context rot cause? Context rot introduces severe operational risks to software development projects. First, context rot causes silent code regressions. An AI model might solve a new problem in a script. At the same time, it reintroduces a bug from earlier in the session. The model forgot the previous fix because that fix sank into the middle of the context window. Second, context rot causes instruction drift. The AI gradually ignores system instructions, style guides, and output formatting rules. It drops required error handling routines that you specified in your initial prompt. Third, context rot triggers circular debugging loops. The model suggests a fix for an application runtime error. The fix fails, so you paste the error back into the chat. The AI then suggests the exact code that caused the initial failure. You waste time oscillating between two invalid solutions. Fourth, context rot introduces security vulnerabilities. The AI forgets security parameters that you defined at the start of the session. It generates functions with unvalidated inputs or hard-coded access tokens. Developers miss these flaws because the code looks correct on the surface. Fifth, context rot inflates operational overhead. Processing large context windows requires higher computational power and increases API token costs. You pay higher prices for lower quality answers. How can these problems be reduced or prevented? Engineers reduce context rot by applying strict context management practices. First, maintain aggressive context hygiene. Do not keep a single chat session open for multiple tasks. Clear the session memory whenever you finish a distinct subtask. Second, summarize project history before sending new instructions. Write a short summary of the current system state. Paste only that concise summary into a fresh session. This habit removes historic noise while keeping essential state variables. Third, implement retrieval augmented generation architectures. These systems store project documentation in external vector databases. The system retrieves only relevant code snippets for each specific query. This design keeps the active context window small and focused. Fourth, modularize your tasks into small components. Do not request an entire application in one prompt. Break software projects into small functions and modules. Provide the AI with only the specific files relevant to the current task. Fifth, place core constraints at the end of long prompts. System instructions placed at the very end override context noise due to positional attention bias. Active management preserves AI accuracy across long development cycles. You can protect your private data by running local AI models on your PC, Mac, or network. Applications and models are available for free, and I can help you get up and running. Contact me for a free demo. You need a PC or Mac with Windows 10 or better, 8 gigabytes of memory, no GPU. More memory is better, but you can run 3B models on 8 gigabytes. They can be impressive. There are several free tools you can use for local AI. GPT, 4, ALL, LM Studio, Ollama, and anything LLM. I have published more than 700 blogs on AI in the past 3 years. If you get value from these blogs, please join my Patreon as a member at the $2, $4, or $8 per month level. https://www.patreon.com/Steve Hovland. I have a new group on Facebook called Local AI by Steve